Hello, it is Tuesday, June 11th, 2019. Today is the first day of class, and as would happen, I've had house painters here who have knocked out my fiber optic internet connection, so I'm on a backup connection right now. I'm going to get this thing uploaded to Canvas so I can do this, and then I'll try to meet live stream. I'm not sure I'm going to have the bandwidth to meet you live stream. So what I'm going to do is I'm going to turn off my video for right now, and I'm going to go to just to share the screen, and we're going to discuss the syllabus, and I'm going to get into the first class. Let's see, share. And then I'm going to turn off my video. Stop video. Okay. First of all, this is the home page for our class. Looks like this. I'm going to look at the syllabus. If I click the syllabus, it doesn't show me anything, but if I say save, it will save it, and then I can open it. And let's see, I might as well turn that on. The real course syllabus, in my opinion, a syllabus should be one page or close to one page. Everybody in the world comes along and puts stuff into it. Summer census date is June 18th. That's coming up pretty soon. I must have the first assignment. On June 18th, you are in the class. If you don't have something turned in by June 18th, then the registrar drops you, and I don't have anything to do with that. All of my exercises have due dates. Just for your information, the cutoff date will usually be 2 weeks, 1 week in the summer after the due date. And this is, I give you a week to the due date, and that's when it should be in, and I cut it off a week after that. So that gives you plenty of time. Watch that cutoff date. That is firm. And the reason for that, I used to just give people, well, whenever you get it in, loosey-goosey. But the problem with it was that people would turn them all in on the last day of class, and that was just yeah, really a bad situation. So I have it be 1 week to due date. You don't have to worry about the due date. If you're not in by the due date, you don't have to make a lot of excuses. Just get it in by the cutoff date. That's usually a week after the due date. Last day to withdraw from the class will be July 11th. But notice this, the Canvas gradebook is set that it does not count late or not turned in assignments as zero. This, in fact, frequently causes students to think that they have a better grade than they really do. But if you don't turn in something, it's zero, of course. It only shows the average. Reason for this is if it goes past due, then it counts as zero and everybody's screaming at me. Record the audio, share the screen. There's my personal meeting ID for real time. I'm going to have a real time. And okay, check the course announcements daily, please. I say Friday before you leave for class because that's a carryover. I commute from Denton. We don't commute from Denton in the summer. Here's the textbook. Take a note of the textbook. You can get that in ebook format from the publisher. You can rent it, and that's not a bad deal. I cannot install your SQL server for you. And the final, I'll publish when the final is to be given. The final will be, this is online class, so the final will be online. Here's a week of 722. We will have one longer lecture on Tuesday. And the week of 729, there will be one lecture on Thursday. That's because I'm going to be out of town. So it'll be Tuesday 1 week and Thursday the next week, and that lets me get my stuff I have to get done. And then we get into the official syllabus. The problem with the official syllabus is that everybody in the world has decided they wanted to add something to it, so it's got all kinds of stuff crammed into it. You don't really need to worry about it. There you have it, though. Here's the course calendar. By the way, this goes through, this is a 16-week calendar, and the summer session is compressed. So this is going to, we will follow this sequence. So this is what's going to happen. So when we're on chapter 3, you're expecting test 1 shortly thereafter. Okay, that said, let's see, what else do I need to do? Oh, You are expected to attend to the lectures. You don't have to attend to the lectures. You don't have to be online at 6 o'clock. You are encouraged to be online at 6 o'clock, but you don't have to be. You will be held responsible for anything I say in lecture. So with that in mind, I'm going to go ahead and exit the syllabus. Go to the modules, and the modules, the orientation. You can take a look at that. Install the SQL Server software. I strongly recommend that for installing the SQL Server, you go to this video down here under recorded lectures. And that's the way I would like it installed this semester, please. If you are installing 2012, it is very similar. The installation hasn't changed a whole lot. Some of the screens may be slightly different. I can walk you through it and try to help. Unfortunately, if there is a problem with your computer and you don't have enough memory, or you don't have a up-to-date processor, or your operating system isn't patched up, I cannot do much with it. So get that installed. It would be better to have Windows 2010, but Windows 10, excuse me. But if you have Windows 7, you're going to have to install SQL version 2012. This is a pre-class demonstration and a little welcome message from me. We're going to start with Module 3. Now, Module 3 has an introduction, and Module 3 gives you the reading assignment, the assigned reading. There it is. And so I'm jumping way ahead. That's what it means, non sequitur. That means that this one is out of sequence. So I'm jumping way ahead to chapter 11 and beginning on page 340. And the reason for this is because I think you need to see how you create a table before you start using them. Okay, so what is database? Let's jump to the next screen. I'll let you read that stuff the next. SQL programming language. SQL programming language is a ancient programming language by computer science standards. It is ancient. It's kind of like staying alive. It's back in the days of disco. It was developed in the late 1960s, and it is still active today. That is highly unusual for a computer program language. So the SQL programming language breaks down into two pieces of it. We have what we call the data definition language. It's really part of SQL, and the data manipulation language, or DML. So DDL, DML. Data definition language involves creating tables and various other things that we're going to talk about today. Data manipulation is retrieving and altering the data that are in the tables. So today we're going to talk about creating tables. So in SQL, the file that we use really isn't a file, it's a table. When you think of a table, I want you to think of a Rolodex. Let's see if I can get to the next screen, and I think I do some. I talk about Notepad++. You can look at this. Notepad++ is a text editor that you may use if you want to. I'm going to leave that up to you. And I'm not going to. No, I'm not going to do that. Oh, stop it. Stop it. Stop it. Creating tables in SQL. Okay, here we go. So when you create a table in SQL, you think of a table as a Rolodex. Think of a table as a box of index cards, if you like. And when you create the table, you are defining a box, and you are telling the user, me or whatever, what goes on to one card. For example, if I were to set up a table of all of my friends, I would start with a box of cards, maybe 3x5 index cards, and I would have to define what am I going to put on each card, because each card has to be the same. So a card might have my friend's name, my friend's address, phone number. The address would probably break into several fields: street address, city, state, zip code. The phone number might break into fields. I might have a field for the area code and for the rest of the phone number. So I have to ask questions about that. Am I going to put the friend's first name and last name in the same field, or will I have a field for first name and a different field for last name? And that it is important to think about that, because how you treat those data will matter later. There are some rules that go with this. And the first rule to go with database is that no two records may be exactly alike in all fields. Now, this comes from the idea of set theory. Something is either in a set or it isn't. So no two records may be exactly the same in all fields. That said, is it possible that there is some smaller set of fields that could do that? And what I want to get to here, can I find one field that will identify at most one record? So this might be like your social security number. Now, I probably wouldn't store my friends with social security numbers because I wouldn't know them. But I'm looking for something that is unique to that. It might be their phone number, unless I have two friends that have the same phone number. So I need something that is unique about each record. So I'm going to call that the identifier, and this is going to be, it could be the social security number, for example, or it could be your driver's license number, or it could be your phone number, it could be your birth date if nobody else could be born on that same birth date. So it's important that we have something like that. Now, when I identify something like that, and I say I'm going to use this to identify one record, that field becomes what we call a primary key. The primary key has two restrictions on it. Once I identify that and I say, okay, here's a social security number. A social security number cannot be null. What would make the best primary key? Name, hair color, social security number. Social security number is the best one. Okay, so if you chose it, that is correct. The others may be duplicated. Everyone has to have a social security number. So hair color, I don't know, if I'm bald, I don't have a hair color. I guess I did once upon a time. If I choose social security number, you have to have one. It cannot be empty. The other thing about a primary key is that no other person may have that same primary key. So that's why we like social security numbers. They have to be unique, and you cannot be here without one. Okay, let's see. To be correct, all tables must have a primary key. So here is I'm saying please open the file, mod 3 create. So here is the SQL. Here's your first SQL, unless you've been working with the others. So the first statement says use the database. Now don't worry about this database. This database says change the database name. That's just some name I'm making up to use. We're going to use ScratchDB. Talk about Go in a minute. Here is the statement. Create table, employees. If I were to execute this statement in my SQL, it would work. Create table. Now, there are the fields. It's got two fields. It's got ESSN, that is the name. Let me go ahead and start my SQL, wherever you went. Okay. To start SQL, I'm going to go down to, I believe it's under Windows. No, under SQL. Microsoft SQL Server, Tools, Server Management Studio. Yours might not be under Tools 18. Yours might be under 2017. But wherever it is, you have something called Server Management Studio. And that is where we will go to run our SQL Server. So we'll let this guy boot up while he's coming up. There we go. When I log into the SQL Server, I'm going to log in with, given that I've done everything, SQL Server authentication. I should have already created, Okay, the server is desktop, SQL Express. You really should only have one of those. If you have more than one, it's you need to figure out which one you're using. Oh, I'm sorry, I'm logging in with Windows Authentication. I want to log in with SQL Server Authentication. And my login name is the one that you created. My name is S.W. Smith. I don't know what you created. It's probably your first initial last name. My password. And I'm going to click Remember Password because I don't feel like putting it in every time. And it freezes right now. Okay, why is it freezing? Well, it's going to come around later, but I can go over here. I go to my Windows services. Now the services I told you to put down here on your quick toolbar, but you find those over here down at Windows Administrative Tools. Under Windows Administrative Tools, you go down to Services, and I would suggest you put this as a quick access toolbar shortcut. Scroll down to the S's until you find SQL Server. SQL Server Express. And notice down here is SQL Express. It is on manual startup type, which is, I told you to set it to a manual startup. Notice it is not running. I forgot to turn my car engine on before I tried to drive the car. So let's turn him on. I'm going to double click. Options are service status is stopped. I want to start it. Now he started. Now I'm free to close this. I'll come back to it later. And he's telling me that this is the error. But now that I have started him, I can say connect, and I don't know what this is. Connect. I'm going to connect with server authentication. I should have seen that. SW Smith. Okay. I don't know what that little glitch was. Sometimes you have to, that should not have happened. Notice it connects very quickly. When you get everything right, he does connect very, very, very quickly. Now, over here, as I go through this, this is kind of the graphical user interface. Not kind of, it is. This is a graphical user interface. It's a little bit like Access. We're not going to use it like that, but hey, we might as well take a look at it, and this is what we can see here. From here, I can see the databases. These are two databases. I have AP_DB. AP is my accounts payable database, and Scratch is like scratch paper. Okay. We're going to be using the Scratch DB. Under security, I can find my login. There's SW Smith right there, and any others that you may have created. And that's really about all we need to worry about. If I look under APDB, I can see my tables. There's all the tables that are created there. So that's accounts payable database. And we'll come back to him later. We're not too worried about him at this time. Right now, I'm going to go up here to New Query. And I have opened a programming window. This is where I will write my programs. So I have a program that I have given you. Let's see. So here's the file. And I can either copy and paste him, or I could save him and open him. I think I'll copy and paste. Paste. That may not have been the best thing to have done. Okay. New query. I'm going to go back here, and now what I will do here is save this guy. Save link. And I will save him as, I'm not sure what I've got here. Under Documents, under Colin 2309, I have a place to save him. Summer 2019, SQL files, module 3 create, I'm going to say save. Here, I'm going to say file, open, and I'm going to go to where I saved him, file. Documents under Colin 2309, summer, SQL files. Okay, so here I have the file created. Now, we're not going to worry too much about these red lines. Red lines typically mean there's an error. Okay, so what I did, I saved that file. What file? This file right here. Please open the file, mod3 create 1 SQL. Saved that file and opened it. Don't worry about the squiggly line. The squiggly line says I couldn't find the file. If it cannot locate the entry. Okay, that's because the database that we have is called Scratch underscore DB. Now, Scratch underscore DB exists, and maybe that squiggly line will go away in a minute. Don't get too upset about that. So ScratchDB was the database we use. So line 5 says, what database are we using? Ladies and gentlemen, you will always select your database. Okay, well, we've come to Go. Let's take a look at it. Go means that make everything happen and then start a new batch. So this is a batch processing script that we're running here. So this is essentially, this divides it into two spaces. So use the database, then make everything stop and create the table. Now, in theory, we should have created the table and done Go again. So Go says we like to have creating the tables. I need to change that in this guy. We need to create the table and then Go. Create the table and then Go if we have anything left. So I like for creating the table to be the only thing in what we call a Go block. Now, when we get later and we're doing selecting data and we're looking at our data, we don't have to have Go blocks. But so we use ScratchDB. We always select the database. In this case, it will be ScratchDB. Please do not use AP underscore DB. I'll tell you when to use that. We're creating a table. The table is named employees. The table will have two fields. The first field's name is ESSN. ESSN, that is an identifier. It's kind of like a variable. So create table employees, then we have an open parentheses, then we have the first field. Notice that the field has a name, has white space, and a type. So the name comes first, the space, and the type. This type is char, character, 9. ESSN has 9 characters. ESSN will always have 9 characters. If you give it fewer than 9 characters, it will pad it out with blanks. So it will have 9 characters. If you give it more than 9 characters, it will give you an error message. Okay, comma. Next field, the second field, is ename. Name has varchar 16. Varchar means variable length character, and this one will have up to 16 characters in it. If you give it fewer than 16 characters, it will adjust the length accordingly. So a varchar can only have 5 characters, but a char field has to have 9. If you don't give it 9, it will pad it out with spaces. So you don't, the difference between them isn't great. Generally speaking, when it's a small field, I will use char. Okay. Line 13 is a constraint. On the constraint, I'm saying that employees PK, I have to give it a name. There is the name of the constraint. It has a primary key, and the primary key is ESSN. What am I saying about ESSN? I'm saying that ESSN 1 cannot be null, and 2 must be unique. Okay. Comma. Constraint, null ename. And here I'm giving it another constraint. This has to be true about the table. I'm saying check that ename is not null. Make sure you have a name. In order to be in my table, you have to have a name. I don't have to say check that ESSN is not null. That's part of primary key. So I get check that that's not null because it's not in the primary key. But the second one, you might not have a name, but because this constraint is there, it will stop you from putting in someone's name who is null. You don't have a name. Note that no comma goes at the end. All statements in SQL end in semicolons. All statements end in semicolons. You will find that SQL Server would not need to have a semicolon. This would work fine, but I will expect that all SQL statements will end in semicolons. Go does not have to have a semicolon. If you put one, that's okay. If you don't, that's okay too. Go is not really an SQL statement. More about Go later. Questions? Well, I'm not live, am I? Employees have dependents. How many dependents can an employee have? 0? Yeah, an employee could have 0 dependents, I suppose. Let's assume that him or herself is not a dependent. So I'm talking about other than self. Could have 0, could just be themselves. Or they could have 5 or 10. We don't really know. So the way we do that that's called a one-to-many relationship is that in the table, I will create a second table for the dependents. In that table, I have a dependent SSN because all tables have to have a primary key. The dependent has a name. And notice this, the primary key of the parent. So think of it as the employee is the parent and the dependent is the child. A parent has 0 or more children. One to many. One parent has 0 or more children. One employee has 0 or more dependents. Now, the way this happens is the primary key of the parent table just gets copied. He's just copied. Notice he's there. The primary key comes over to the dependents table. Over here, he is called a foreign key because when I read the dependents table, I see that this dependent belongs to this parent. So the dependent has a primary key and the dependent has a foreign key. So when I say constraints, dependents PK, primary key, what am I saying about DSSN? I'm saying it cannot be null and it must be unique. So no two dependents may have the same social security number. Don't have any constraints on the dependent name. Hadn't put one. All right, the constraint on ESSN. It is a foreign key, so DSSN, usually when I do this, I come down and put him on the different line as he gets long. Constraint dependence employees foreign key. Foreign key, ESSN, this is a foreign key. References employees, ESSN, that tells me that he go up here and look at this one to find to whom he belongs. So I'm setting that up here. I'm talking about ESSN. In the dependents table, here I'm talking about ESSN in the employees table. Now, they do not have to be named the same. I recommend that you keep them named the same. They do have to have the same type. For example, if I have char 9 here, I have to have char 9 here. I can't have one of them be a char and one of them be an integer. Okay. Excuse me, I meant here. Char 9 here. These char 9 in the employees table, the foreign key has to be a char 9. One of them can't be an integer. That wouldn't match. Different systems handle that differently, but it's always an error. I will always keep the same name. Now, notice my naming convention, and I do this quite a bit. Notice that what is this table? This is the employees table. I chose these names. Notice the names I chose begin with ESSN, employee.ssn. E name, employee name, and then the names. This is the dependents table. What did I choose for my name of my primary key? DSSN, why? Dependents. D name, why? Dependent. Oops, here's one that's different. What does that tell me by looking at it? It tells me that that's taking me to a different table. Okay, this is my way, and I'm going to be discussing this naming convention as we go down through here. So as I have these two tables set up, I can have an employees table, and I can have Al and Bob and Charlie up here. And Al can have SSN 1, and Bob is 2, and Charlie is 3. Now, a dependence. So if I have a dependent, remember Al is 1, Bob is 2, Charlie is 3. If I have a dependent called, I don't know, Stephanie, and Stephanie, so DSSN, I don't know what her social security number is. I guess it's 9. Her name is Stephanie. If she has ESSN 2, who is her sponsor? Well, Bob would be, because Bob is ESSN 2. So in this schema, I can have as many dependents as I want to have, and they can be, so I could have 0 or more dependents, and I'm not duplicating any data except for the ESSN. And this is what we mean when we say related tables. I'm going back now to this guy. So that's the database. Comments. Couple of little things about little fussiness that I have. Many database products, Oracle for example, do not accept completely blank lines within a statement. Now let me clarify that. This line right here that I've just put in, those 3 lines, are not within a statement. They're outside the statement. They don't matter. Everything's fine there. Having a blank line here is fine. Now, once I go into this, I am inside of a statement. Many database products would not accept a completely blank line on line 13. Therefore, if you want to put a blank line, I'm going to ask you please to put a comment, -- on that line. -- means ignore everything after this on the line. Okay, but it's not a blank line. You'll use -- by the way, these also work. We call these the C comments. This is also a comment. This is a multi-line comment. I don't use that as much. So use a comment to put your name, develop a heading, tell me what you're doing in this guy. So basically we're creating 2 tables. We're creating the employees table, dependents table. They are related tables. I pointed out they need a go between them, because anytime you use the word create, you should have a go before that statement and after that statement. If you are doing something else, for example, like select from where, it doesn't matter. I'll talk more about that when we get there. I'm not there yet. But for right now, when you're creating stuff, go, create it, go. Then I create something else. Then if I had anything else down here, I would say go. I don't have to because I've come to the end of my program. So if you put it there, it wouldn't hurt anything. There wouldn't be anything wrong with having a go. There's nothing wrong with having a semicolon, but you don't need one. An SQL statement is essentially open format. There is no particular rhyme nor reason to where it falls. You'll see people write it in all kinds of terrible ways. I am fussy about formatting. I like to see it formatted. Now, when I say I'm fussy about formatting, that doesn't mean that I'm going to be sitting here trying to ding you. I'm going to try to show you how I want it formatted. And for right now, just do the best you can and it'll be good enough, trust me. Okay, so let's go back. Sets the database. My biggest bear is not having the database set correctly. Oh, you used the wrong database. Use, what is this one? Scratch DB, which one we're using right now. This is a demonstration. Creates the table, comment, line 10. You can't be in here without a name, right? No man with no name here. And then I talk a little bit about employees and dependents and the foreign keys. So this is the foreign keys. If the employees, if I have 1, 2, 3 is Tom and Bob and Bill and Jane, then the dependents are Ralph. Ralph as 987 is Ralph. Who is Ralph's parent? 3, 4, 5, that would be Bill. Who is Waldo's parent? 3, 4, 5, that's Bill. Who is Tom Jr.'s parent? 1, 2, 3, that's Tom. Who is Sally's parents? 4, 5, 6, that's Jane. Well, what about Bob? Bob doesn't have any children. That's fine. So this way gives us the easiest way to set up a database, a one-to-many relationship where one parent has many children. You'll find this all through database. So one customer may have many invoices, and we're going to see that set up all the time here. When I create a foreign key, let me go back here. When I create a foreign key and I say constraint that it's a foreign key, so ESSN is a foreign key. Can a foreign key be null? The answer is yes. That is called an orphan. That is a child with no parent. That is not wrong in database. You can have orphans. Let's see. Can I have a foreign key that is the same as someone else? So can one parent have 2 or more children? Absolutely. Foreign keys do not have to be unique. It would kind of defeat the whole purpose. That would say you could only have one child, and it's a one-to-many relationship. We'll talk more about that as we get to it. Can a foreign key, if I have a parent, so if I say my parent's name is, or my parent's ID is 456. That 456 must appear in the parent's table. 456 must appear in the parent's table. Okay, so I'm not saying you have to have a parent. You don't. You can have no parent at all. That would be acceptable. Well, if you say it isn't, then you can make it not be acceptable. But just database in general, it's okay not to have a parent. It's okay to have duplicate foreign keys. So it's okay for 2 children to have the same parent. That's fine. But if a child has a parent, that parent must appear in the parent's table. No bogus parents. Fair enough? Okay, so let's go back over here. If I were to try to put in a dependent with the parent ID 567, there is no parent named 567. So that one would be rejected because it could not be. This is the example of creating the table. Next. Here's a little discussion of it. I'm going to go to the modules. I don't want to. Okay, great. Okay, so here is your guided practice. Your guided practice will be pretty easy. Doctors and patients, I've already done it for you. And I do want you to do it. So kind of close your eyes and don't look at the answers. And try it. So a doctor has a unique identifier. What is that? Primary key. Doctor has a name, D name. Doctor has an address, city, street, city, state. I see this as 3 fields. Doctor has a phone number. Okay, it's not a number, it's a char. A phone number, you don't add, subtract, multiply, and divide them. All of these guys are character fields. We're going to talk about integers and numbers. We're not really to numbers yet. So right now it's just char or varchar. You're free to use just char for everything and just make it big enough. How many for a phone number? I'm thinking 9, I believe. And a doctor has 0 or more patients, i.e. there's a foreign key working here. A patient, a unique identifier, i.e. that's their social security number. That's the primary key. So if you call it SSN, that'll be fine. A name, a street, and exactly 1 doctor. So that means that the doctor's unique identifier comes down to the patient. Thus we have a one-to-many relationship. Open an SQL file, and write the program and run it. One little issue we will deal with here is if the tables already exist, it's gonna bomb. That's a bummer, isn't it? Okay, so we're going to use this. This is going to be use scratch underscore DB. And if, okay, here's the statement. This is not pure SQL. This is actually reaching over into the next class. SQL does not have if, then, else built into it. Well, it kind of does, but it really doesn't. If the object ID, patients, is not null, drop table patients. So it says if it, it's a little strange. It says if the object ID does not exist, then drop it. If you think about it, it's not as, quit thinking about it so much and just do it. Now, the important thing to point out here is that remember that the parent has to exist. So if I drop the parent first, then that will make all of my children have invalid parents. That cannot be. Therefore, I have to drop the child table first. Then I can drop the parent table. Drop the child table first, then drop the parent table. Now create the parent table first, then create the child. I talk about some naming conventions. Rules for names are just like they were in almost any other language. They begin with a letter, followed by 0 or more letters, underscores, or digits. Cannot be a reserved word. We're going to talk about Go in detail when we get further down the road. So basically, we'll use Go before and after a create table. And then until we get to it later, you can just forget about it. When you have finished, compare your solution to mine. I give you the solution. So try it, then compare yours to mine. See if you think yours might be just as great as mine is. You might have just used different names and a different format, and that's all fine. Go to next. The next one is our programming assignment. I am very fussy about the format of your code, but don't get too intimidated about that. I'm also kind of a wimp when it comes to, if you're making any attempt at it at all, I'm fine with it. Open a new file, name it this, name it whatever. Programmers do take names seriously. Yes, okay, I agree. So this is, so we're going to have pets and owners. So pets and owners, what table you can create first? You have to create the owners table first. Owner has a unique identifier, yabba, yabba, yabba. A pet has exactly one owner. An owner has 0 or more pets. When you see that language, that tells you which one is the parent and which one is the child. The parent is the owner. The child is the pet. The parent gets created first. The owner gets created first. The pet gets created second. The pet has to get dropped first. So when you say if object ID pets, I think it was, is not null, drop table pets, that has to happen before the owner can be dropped. Choose appropriate lengths. Okay, for example, I won't argue if you tell me that you're going to allow 16 characters for the person's name and somebody else says, oh, I want it to be 24. I'm just going to say, fine, you're both right. Okay, on the other hand, if you're only giving me 4 characters for your name, that's too small. Varchar 256 is way too big. Check your file name. I'm not as worried about the file name. If your file name, if it looks like you're making sense out of it, please do not zip your files. That just adds another area, another step that I have to do to run them. So just, these are going to be small files. We're not going to have a whole lot of really big stuff here. They're going to be text files. So don't zip them. Fuss over your format a little bit. And as we get through into the class, you'll fuss over it a little bit more. Right at first, I certainly won't take points off because I don't think your code is perfectly formatted, since I haven't really told you what I expect you to do with formatting. And finally, place your name and a first line comment, and then oh, this is important. Run your file to make sure it works, and then we'll work from there. Just basically, we're here to learn, and I'm not here to just beat you over the head with a bunch of stuff. I'm here trying to teach you SQL, and you're going to have to just work with me, and we'll get this formatting stuff down. We'll get it down, and the questions you have, I will answer them. Try not to get too upset about it, but do keep up with the class. That's the important part. I will be available on Tuesdays and Thursdays for sure. And maybe if you can't meet me on Tuesdays and Thursdays, we might come up with a third time for tutoring or something like that. And I'm sorry that I had to pre-record this lecture. From now on, they will be live streamed. Trust me on that. So well, I say trust me. I'm hoping I can have my system back up by Thursday. So hopefully Thursday will be live streaming. For right now, I'm going to go ahead and end the class and get this started. Now, what you'll see me do when I run to the end of the lecture is I will go to the, I'll go down and I'll turn off the share. Then I'll turn off the recording, so the recording is about to end. Then I will end the meeting. So I'm ending the recording.